Hi everyone, my name is Emily and I am currently in the DMS program here at LCC. For my Starscapes presentation, I'm going to be focusing on the receiver of an ultrasound machine and what steps need to occur for the machine to function properly. First off, I'm going to give a little bit of background information about how ultrasound works. Sound waves are sent into the body through the transducer, also called a probe. Those waves then encounter various parts of anatomy within the body. Those can be organs, muscles, blood, nerves, etc. Those waves are then reflected back to the transducer as echoes. The differences in waves will produce varying degrees of grayscale images. There is a lot more detail that goes into each and every part along the way, but that is a quick tutorial of the basics. So what components make up the ultrasound system? Typically, there are 6 different components: the transducer or probe, pulsar and beamformer, receiver, which we will talk more in depth about today, display, storage, and master synchronizer. The diagram on the right shows the flow through the system. So how does the receiver fit into the system? Like we said earlier, the echoes return from the body into the transducer as sound waves. They then are converted into weak electrical signals that get sent to the receiver. The receiver then prepares the weak signals so they can be displayed. There are 5 functions that the receiver must do in order to process the signals correctly. The 5 steps in order are amplification, compensation, compression, demodulation, and rejection. I'm going to be breaking down each one of these steps today. First, we have amplification. There are 2 portions of it. Pre-amplification is done automatically by the machine. The weak signals are made larger. This typically occurs in the transducer and must occur so the machine can further process the signal. Then we have amplification that can be done by the sonographer. It is also known as receiver gain or gain, and this is adjusted by moving the gain knob on the control panel. It is measured in decibels or percentages. The next step is compensation, also called time gain compensation, TGC, depth gain compensation, DGC, or swept gain. As the sound waves travel through the body, the waves get weaker. This is called attenuation. When we don't have compensation, objects in the near field or top of the screen will be too bright, and objects in the far field or bottom of the screen will be too dark. Additionally, weak reflectors will show up a dark gray, and strong reflectors will be a light gray or white. The image on the right shows the differences between an image that is uncompensated versus compensated. Modern-day ultrasound machines have automatic compensation systems, but the sonographer still may need to make some adjustments. The TGC controls let the sonographer adjust the image at their respective depths. The picture shows the different sliding toggles that help compensate the different depths to make the image more uniform. This is also measured in decibels. The third step of the receiver is compression. There are also 2 parts of this step. The first compression is done automatically by the machine. This is required to keep all the information within a range that the machine can use. It compresses the information without losing the essence of the original information collected. The second compression is done by the sonographer. It is called dynamic range or log compression. This is an additional condensing of the shades. The darkest shade will remain the darkest, the lightest shade will remain the lightest, and the in-between shades will reduce in number. Compression is also measured in decibels. I also added an interesting fact here. Ultrasound machines are able to display 256 different shades of gray. However, the human eye can only see about 20 different shades of gray. We are not limited by the machine, but by our own ability to distinguish the slight color differences. Next, we have demodulation. This is also known as detection. This step cannot be adjusted by the sonographer at all. Everything is done automatic by the machine. The wavelengths of information that are received from the body have variations that are above and below the baseline. The machine cannot process the information this way, so two different steps need to occur. The first is rectification, and the second is smoothing or enveloping. In rectification, all the negative voltages that are below the baseline will be flipped above the baseline, but still at the same amplitude. Secondly, smoothing will happen. Variations of voltages are reduced slightly, which make a smoother line. To demonstrate this idea better, I added a few images. The first image at the top of the screen shows the original signal. The next image shows after rectification, all the voltages are above the baseline. Then the third image shows after smoothing, where you can see a simple arch of voltage that the machine can then interpret. The final step of the receiver is rejection. It is also known as threshold or suppression. Some of the signals that return from the transducer are important information, and others are meaningless noise that can distract from the needed information. The first rejection is done automatically by the machine. The second rejection is done by the stenographer. This allows the stenographer to decide if they want low levels of echoes to be displayed or not. When the stenographer increases the rejection, it decreases the amount of those low-level echoes seen, therefore cleaning up the image. So, what happens next? The information will then go through the master synchronizer and display. Finally, storage if the image is being kept. All of these steps are happening over and over again in a fraction of a second. The receiver is only one small part of many that must occur for the ultrasound system to function correctly. Finally, these are my references used, and thank you for listening today. Hopefully you learned a little more information about how the ultrasound machines function and a part of what a stenographer does for each image they take.